All right, let's get started. First thing we need to talk about is some housekeeping. So let me get the sign-in sheet passed around. So I'm going to actually defer to you all a little bit on this, and so let me explain. So today I was going through thinking about what are we going to talk about today, and I know I want to finish our discussion of dynamics because we didn't quite finish it last week. So I'm going to do a review of that. I don't really want to dive into mechanics of materials because I kind of get the feeling deformable should get its own week. So we do have time today to cover a topic that we skipped. So we're going to talk about ethics today, ethics on the exam, okay? So that's what we're going to do today. This is where I need your input on something, okay? So we're going to have a little bit of a group discussion, so everybody pay attention. First up, I told you all at the beginning that right around the beginning of October, things are going to get a little interesting for me. Well, it's September 26th, which means next week is the beginning of October.
Freaking out?
Not really, but I'm excited. I'm excited, but I know things are going to get interesting. I need your attention on this. Okay, so we have one more remaining topic in what I would call general engineering, and that's mechanics of materials. Okay? After that, we're in civil engineering land. Okay, now, this is me making a prediction. I don't know that I'm going to be here on October 3rd. I'm guessing, okay? You know, her due date's October 4th, you know, so let's just live in the world of reality. So here's what I'm getting at. I'm going to make a prediction right now that this week and this week might be an online lecture. One of the two, maybe both, I don't know, okay? So I'll do a video online, post a quiz, and we'll do that. Okay, now, here's what I'm getting at. I can skip doing mechanics of materials online if you would like to do it in person, okay? I get the feeling that you know, some of you might feel like a mechanics of materials or mechanics of deformable body session would be better in person as opposed to me doing just a video online, okay? So I'm happy to put mechanics of materials off to when I know I'm back here in person. We can do that in person, okay? Would you want me to put mechanics of materials off to do it in person, or are you okay with me doing it online?
What would be the topic that gets done?
Hence the discussion. If I am going to do a topic online, what would you like me to do online? And I came at this with a suggestion in mind. I know you all know structures because I know who taught it to you. Well, whatever section I'm doing, I mean, it's me sitting there lecturing and doing problems, so it doesn't really matter what I do. But here's what I'm thinking. I get the feeling that you all are going to want to hold off on doing mechanics of materials till we're in person, and I've been hearing this geotech word pop up for a little while, and I get the feeling you want me to do that one in person too. See what I mean?
Yeah.
What's that?
I would like structures. Structures online.
So I have two structural lectures, okay? And one of them is structural analysis, and one of them is structural design. Now, here's the thing. When I do the structural design lecture, if I do it online, I am going to do some steel in it. Now, I know everybody's like, well, you know, I haven't had that. That's fine. First off, we're having it next semester, so that's going to happen. And two, the stuff that I do in the lecture is pretty straightforward. Like it's some more of the straightforward stuff. I don't get into the really out there stuff. In fact, when we do some of the reinforced concrete stuff, it's actually pretty basic on the exam. It's not like really, really out there stuff. It's pretty straightforward. So I'm thinking that what I'm going to do is if you all are okay with this, after dynamics and ethics, we skip mechanics and materials. And we do structural analysis and structural design these weeks. Okay, so this is a slide. I can edit it. Let's edit it because we're all in this together. So let's see. So we'll do this. We'll say this is structural analysis. And this structural design. So that would make this mechanics of materials or mechanics of deformable bodies. Okay? Now, after that, we are in civil engineering world, period. Okay? So let's talk about that. Okay? How many weeks do we have left after that? We've got the 24th of October, and then, so let's see, hold on. All right, so let's see, we got 24, what's that? It's going to be this. I might have you do, when we start getting into the November time frame, we might get a submission from you all, like a short submission on senior design, but it's not going to be a big deal. Y'all's senior design experience is going to be concentrated in next semester, that's for sure. So let's look at civil engineering lectures. We'll have the 24th, we'll have the 31st, the 7th, the 14th, the 28th, and the 5th. So we've got 6 lectures on civil engineering related topics, and civil engineering related topics that aren't structures, because if I do those on the 3rd and the 10th, we've got structures out of the way, okay? So 6 lectures, okay? So we can plan this out if you would like, so 6 lectures. Because I'm also, here's another thing, I'm also fine with going out of order if there's a particular topic you'd like to see first, okay? So let's go through the exam, the exam criteria, and let's see what we've got. Like I said, involving you all. And I'm going to talk about this correction to problem 4 here in a second. But this is going to open. All right. So let's go through this. We've already done math. We've already done probability statistics. We've done computational tools. We're going to do ethics today, done econ, done statics. We're going to do dynamics today. And so now we're in civil land. Like I said, we're going to skip structural analysis and structural design because I'm doing that next week and the week after. So that yields fluids. Now we have materials, but usually the materials questions you get on the exam are more conceptual in nature. I mean, you might get some stuff on, like when I say materials, I'm talking about civil engineering materials, like sieve analyses and things like that. But usually it's pretty conceptual in nature. We got fluids and water stuff, so like hydro or H&H, geotech, transportation, environmental, surveying, and construction. Okay, so let's sort of split these up into a few different topics. Okay, geotech, I could feasibly see geotech being 2 lectures because one lecture would be geotech and the other would be foundations. I could see that. I could see us doing that. And if you would like, I'd be happy to plan 2 of these lectures to be geotech. Okay, all right. So we'll say geotech 1 and geotech 2. Okay. Now, let's continue with this. Okay, so we've got water, transportation, environmental. Okay, I'm going to be honest. Unless I can get Dr. Yoon to make his schedule available to come in and do environmental, I'm not doing environmental because no. That's a good question. That's a good question. Hold on, everybody. We got to make sure everybody's here. So the question was, what's construction? Okay, so construction is going to be a couple of things. It's going to be some general info on just construction practices, like what's the difference between design, bid, build, some things on management. You'll see stuff on critical path, estimation. A lot, look, in all fairness, the FE style questions that you get on this are pretty basic. We can talk about it. Here's sort of what I'm thinking, if you want to talk about management. This is sort of where I'm thinking. We have 2 geotech lectures. I'm thinking we could have 2 water lectures, okay? One on fluids and one on like hydraulics and runoff and things like that. And then our other 2 lectures, I'd like to sort of blend construction, surveying, and transportation. And I think that that's sort of how we can finish this out. I'm not doing environmental, but we're also, there's an issue with time. Like there's all these topics on the exam, and I don't know that even I have time to cover every single one. So, yeah. Really? We can skip that. If you want to do that, we can. Well, that's a good point. One thing you'll find is that, and I'm not trying to say it's all one big topic because I know there are nuances, but like a lot of the water stuff on the FE is kind of like it's all the water stuff, you know. And there are some very classic problems that all sort of fit together, like manometer problems are very classic problems for the FE. You know, here's pressure A, here's pressure B. What's the difference if you've got this much mercury and this much water and this much gasoline and all that? That's a very common fluids problem. So that is common. So are we thinking one water lecture, like one big water lecture?
Yeah.
Well, hold on. What were you going to say?
So if you was to leave a section out, say you spent more time, on transportation and not on fluids, would it be a possibility to have what you didn't cover, maybe like an optional online?
I might try. Well, I'll say this. I might try and put a video together if there's something that you all are that we miss that you all desperately want. Okay. But I'm not doing environmental. Right. Like I'm sorry. I know my limits. And biochemical oxygen demand, that's one of them. Yeah. That's a good question. What's that? No, but you can't. No. In all fair, no. You can get questions related to, for instance, completing a differential level, to azimuths and bearings, traversing. Like those, you definitely can get. One thing I will say about the surveying section, the Casio really does shine there because Casios do a very good job of handling degrees, minutes, and seconds. A very good job, and there's a lot of that in those calculations. So. Well, I think it depends on where we end up. Like, I wouldn't mind doing a quick example online of a mixed design, because I don't know that a mixed design warrants 2 hours of our time. But I can put a 20-minute mixed design video in a playlist. I don't have a problem with that. Or a sieve analysis. Sieve analysis, it depends, because we might do that with Geotech. We might do that with soils. So if we do a sieve analysis in soils, I'm not doing it again in materials, because it's the same. 2 geotech. That leaves 2 more. Surveying and construction. We could do surveying and construction one day. So how about this? So we've got transportation. One water. And then surveying. Surveying and construction. Well, we can do this first. Like, I'm just listing them, but we can make sure that that's a good point, though. We can do surveying and construction first and then do transportation, because you're going to use curve stuff in this. In fact, honestly, like the way I view a lot of the stuff on the FE, a lot of what you did at the end of Geomatics and what you do at the beginning of this class are kind of the same. And that's actually a lot of what's on the FE. So you will get horizontal curve problems. You will get vertical curve problems. We got one more. That's what I'm saying. I tell you what I will do, okay? Let's do this. I will try and see if I can get Dr. Yoon to come in one day, and do an environmental session with you.
Yeah, I mean, we can always split water up.
Well, how about this? Let's do this. Let's move this up. So okay, how about this? 1, 2, and we'll make this one 3, make this one 4, and we'll put water off at the very end, okay? Because if water, so that'll be our next to last one. If we need more time with water, we'll do another water lecture. If we feel like we're good, maybe get Dr. Yoon to come in and do the last one. What do you think? So ethics is what we're talking about today? No. 6 is dead week. So 6 would be dead week. So no, I'm not. I had debated putting like a 2-hour online, just quiz of everything, but I'm like, no. What's that?
2 hours.
All right. Is everybody okay with this moving forward? Everybody okay with that? Everybody feeling good? Okay, all right. Okay, before we get started, I do have, so here's what we're going to do. I only have 3 dynamic problems for you to do today, but I do want to correct a mistake I made last week because I'll go ahead and pull this up. So we did this problem, and I'll just flat say it. My solution was wrong. And the reason why is because I feel like when I was writing this or doing the solution, it was like I was doing a different problem. And I was doing it in class, and everything was making sense. And then I got a really good question, and I went, wait a minute. That's right. Whoops. So, and that's essentially what happened, is that I did the problem incorrectly. What ended up happening was this. The question was in relation to the friction, and that if you're pulling the block up the hill, wouldn't the friction also work against you? And what it boiled down to is that when I was doing my free body diagram on the block, is that I had friction going the wrong way. So when you're pulling the block up the hill, yep, friction's working against you. When the so I had the block going, the error for friction going the wrong way. All the calculations were correct, but the big thing is when you sum forces in the x direction, friction's on the other end. So instead of getting 44 kilograms, you end up getting 76 kilograms. So I was incorrect on that. Whoops, my bad. I posted this on Blackboard. So I've got this, like if you go into the statics and dynamics section on the lecture notes, I posted this. So this is the actual correct solution to problem 4. Apologies for confusion on my part, but that's what happens when you do problems like 20 minutes before class. So, I know. But at least I owned it, and so we can add 1 out of, remember 7 mistakes? So we got 1. I'll admit it. It's like if we did environmental, it'd be like 12. So, although I will say this about environmental, a lot of the questions that you get on the FE are all about units. Like you'll have moles and joules, all this, and if you just like multiply and divide the numbers so that the units work out, that'll get you like half the way there. I'm sure like an environmental engineer heard this and went, "You've got to be kidding me. You're making it too simple." All right. Okay. Let's get into the world of dynamics. So all right, everybody, let's recap where we left off. This is where we left off last time. We were doing problem number 6, and this was sort of shaking off the cobwebs, if you will, on some basic physics. Like the final velocity equals the initial velocity plus a times time. You might not have used this stuff directly in dynamics, but I'm fairly sure that you all probably would have used this in like physics, right? Am I right? Have you all seen this stuff before? Bless you. Kinematics, yes. The reason I'm bringing this up is that when you actually get to the dynamics section of the exam, it is going to be a lot like this. It's going to be a lot of basic physics. This problem was really just meant to get you a little more oriented to some of these basic dynamics problems. What we're going to do is continue on with this and just sort of keep on trucking, okay? So what I have here, all right, everybody pay attention. All right. So what I have here is I have a 550 kilogram mass that's initially at rest, and it's acted upon by a force, okay? So I have the force defined as a function, and the question is, what is the displacement of the mass at t equals 4 seconds? This might seem like a really, really funky problem, but it's actually a lot simpler than you would think, okay? So there's a little bit of work to do in this problem. I'm not going to lie, there's a little bit of algebra and a little bit of grunt work, but this is actually a pretty broad exercise of basic fundamental relations in dynamics. And sort of here's sort of what I mean, okay? So let's take a look at this, okay? Would you agree, okay, we have a force that equals 50 times e raised to the t power. And there's a reason why this problem is using e to the t. There's a reason why that exponential is being used. Now we have a mass of 550. Okay, and I'm going to leave units off because everything is consistent. It's all kilograms, meters, and so on and so forth. So if I have a force and I have a mass, what can I determine? Acceleration. Okay, so how do I determine that if I have a force and I have a mass? F equals ma, so A equals F divided by m, right? Everybody okay with that? So therefore, so we have 50 e to the t divided by 550, and so that's 1 over 11 e to the t. Is everybody okay with that? Pretty straightforward. Now, okay, the problem is asking for displacement, okay? Does anybody remember how you can relate displacement to acceleration? Here's a simpler way of going about it. How can you relate acceleration to velocity? Does anybody remember how that works? Say it again. The derivative of velocity is acceleration. It's the change in velocity. So what's the relationship between velocity and position? It's a derivative. So ultimately what we've got is a second derivative going on. But the problem is we're going backwards, okay? Here's what I mean. So would you agree that acceleration is the derivative of velocity with respect to time? Would you agree with that? Okay, so if I have this function for acceleration, how do I determine velocity? You integrate. So we have to integrate the acceleration. Okay, so that means we have to integrate 1 over 11 e to the t dt. Okay? No. What we're determining is a function, okay? What we're determining is a function. If we were integrating the whole thing, this would be like, that's a good point, but we'd be taking like an energy approach if we were doing that using a definite integral. Here we're just trying to find the function. Now, like I said, there's a reason why we're using e to the t. What's the integral of e to the t? E to the t. So that's 1 over 11 e to the t plus what? Plus c. Okay, so what I'm going to do is I'm going to call this C1, okay? And the reason why is because if we're trying to determine position, we're going to have to do this again, right? Okay, all right. Now, in order to determine that arbitrary constant, you need boundary conditions. In other words, those constants are defined by bounds on the problem. And there's 2 words in this problem that'll give you all the boundary conditions that you need. And what are those 2 words? At rest, exactly right. Okay? If an object is initially at rest, that means that its initial position is 0 and its initial velocity is 0. It's not moving. It's sitting there. Okay? So here's what I propose. I propose that at t equals 0, the velocity equals 0. So therefore, we have velocity equals 1 over 11 e to the t plus c1. So that means 0 equals 1 over 11 e to the 0 plus c1. So what is e to the 0? What is anything raised to the 0 power? 1. So that means I have 0 equals 1 over 11 plus c1. What is c1? Negative 1 over 11. So that means that v is 1 over 11 e to the t minus 1 over 11. Does that make sense? Now we do it again because velocity is defined as the derivative of position with respect to time. Okay? So we just go through and do this again. So therefore, the position is the integral of the velocity. And so that's the integral of 1 over 11 e to the t minus 1 over 11 dt. Okay, and so that is, what is that? So we have 1 over 11 e to the t minus, what's the integral of 1 over 11? 1 over 11t plus, and we'll call it c2. So we'll see how this is going? So again, initially at rest, okay? So at t equals 0, x equals 0. All right? I guess technically that's not an at-rest condition, you know, but if we're trying to determine the total displacement at a given time, the easiest thing to do is say, well, it didn't have any displacement at the beginning. Let it go 4 seconds. Let's see what the displacement is. So therefore, we have 0 equals 1 over 11 e to the 0 minus 1 over 11 times 0 plus C2. What is C2? Does anybody know what C2 is? Go ahead.
Yeah.
Negative 1 over 11. Yeah, because this is 1 over 11. That's 0. So it's 1 over 11 plus C2. You're exactly right. Minus 1 over 11. So therefore, we have a function for x. Okay? So we have a function for x. It is 1 over 11 e to the t minus 1 over 11t minus 1 over 11. That is our function for x. What's the problem asking? What's the displacement at t equals 4? Plug in t equals 4 here and see what you get. By the way, do you all know how to use or do exponentials on your Casio FX115 ES Plus? You should. You could. But you won't have MATLAB on anything. Although they kind of will ask you questions about MATLAB, all the structured programming stuff. Yep.
Like once you get the velocity equation, you just plug in anywhere from 0 to 4 use that answer. On Casio, you just do like integral from 0 to 4 velocity equation.
And a definite integral, and it works out? I think, well, you also have to keep in mind that your lower limit just happens to be 0. You know what I mean?
Yeah, but your time's always at start.
Not always. You see what I mean?
Yeah. So, I mean, you can do it from your start.
Yeah.
You don't find that it's fast constant. This one wasn't hard.
The problem with that would work, but let me also say this. That'll work only to get a given value, but it won't give you the function.
Right.
Yeah. I'm trying to go through that process too, so.
Yeah, I was just wondering, do you know if there'd be
I think a Casio will do a double integral. Will it? I actually don't know if the Casio will do a double integral.
you could do,
I'm actually not sure. Will it? I don't think it will because you have to define two variables, and I don't think it can handle that. What? But what did you get for t equals 4? What'd you get? 4.51. Okay. All right. See, is everybody okay with that? All right. I like this problem. I'm sure you can hit the button all day long. I mean, honestly, I didn't know if the Casio would do multiple integrals. I didn't know that it could. I mean, it might be able to. I don't know. I just didn't think it could handle multiple variables. Maybe I'm wrong.
What I don't understand is, like, you know how at the very beginning we set A equal to F over M?
Yes.
If you plug T in there, just like acceleration, you get like 4.96.
Hold on. Hold on. What happened?
I got a syntax error.
What is going on? All right, say that again.
So like the 550 or the 50E for T over 550, if you plug 4 seconds in for T right there, you get 4.96 for your A.
So that's its acceleration at that time. That's not its displacement. That's its acceleration.
Oh, it's not acceleration.
No, because since our force isn't like if you have a constant mass but your force changes, then your acceleration is going to change. So you could sort of think of it as like here's the object and you're sort of like pushing it harder and harder as time expands or as time goes on. Because the force is exponentially increasing, so the acceleration will as well. It's not like an object that's falling. If an object's falling, then A would be constant. And so you'd have a linear velocity and you'd have a second order change in position. So this is good stuff. I like it. Now, one other situation that we need to deal with in the dynamic land is conservation. Okay? So we have, so here's the soils problem for you. So we have 2 kilogram ball of clay moving. It's a soils problem. We have a 2 kilogram ball of clay that is moving at 40 meters per second, and it collides with a 5 kilogram ball of clay moving directly towards the first ball with a velocity of 10 meters per second. So what's the final velocity of both of the balls stuck together after the collision? Let me ask you a question. When you think of masses and you think of velocities, what term in dynamics pops into your head? Mass and velocity. Say it again. Momentum. Okay. So here's sort of what we've got going on. Okay. So we've got mass number 1. Okay. So it has a mass of 2 kilograms and 40 meters per second going this way. And then you have this, you have a mass going this way. Its mass is 5 kilograms. But here's what I'm going to do with its velocity. Okay? Its velocity, I'm going to say, is minus 10 meters per second. Why am I saying it's minus? Because it's going the other way. And when I add momentums together, one has got to have an opposite sign. Okay? So would you agree with this, that its total initial momentum, so we'll call it its MV initial or rho initial, whatever you use for momentum, is going to be m1 v1 plus m2 v2, okay? And so what is that going to come out to be? Well, it's going to come out to be, let's see, 2 times 40, and then you got 5 times 10, or so 80 minus 50, so that's 30, right? Is everybody okay with that? So 30 meters per second, or kilograms times meters per second. Okay? Now, that actually tells you something quite interesting, okay? First off, the initial momentum came out as positive, okay? So if the law of conservation of momentum holds, which way is this moving when it collides? Moving that way, right? Because positive momentum is going this way, negative momentum is going this way. We know which way it's moving, okay? Now, let me ask you this. What is the final mass going to be? M1 plus M2, which is 7 kilograms. All right? So, if the law of conservation of momentum holds and my initial momentum must equal my final momentum, what do I do? Say it again. There you go, because here's what's happening. The initial momentum has to equal the final momentum. Law of conservation of momentum. So we know the initial momentum, and we know the mass at the end. The velocity at the end is the initial divided by the final mass. So what is 30 divided by 7? Oh, man. Living the dream. All right. So, what do you think? Any questions? Like this, honestly, this is straight out of, reference material. This is straight out of what you're going to get on the exam. So this is dynamics. No IJKs. What is this? You want me to just stay up here and do it? Yeah, I'm not good enough. Oh, goodness. Okay. All right. Little bit of circular motion, little bit of centripetal acceleration. So don't worry. This was pretty simple. It's plug and chug. All right? So we have a child that keeps a 1 kilogram toy in the airplane, flying horizontally in a circle by holding it onto a string that's 1.5 meters long. So basically the kid's doing this, like lasso. The string is always in the plane of the circular flight path, okay? Now, what does that sentence tell you? It tells you that the kid is swinging the plane. It's not like the plane is going up. It's just a circular motion, okay? So the problem is telling you that not to overcomplicate it, but to simplify it, okay? Now, if the plane flies at 10 meters per second, what's the tension in the string, okay? Here's what I propose is what's going on, okay? I propose that we have a mass that is 1 kilogram. We have a velocity that's 10 meters per second. We have a radius that's 1.5 meters, okay? Now, what we're trying to determine is the tension in the string. So basically what we're trying to determine is this, think, tension is a force, right? We're trying to determine the force in the string. So ultimately, we're trying to determine centripetal force, right? So let's see. Oh. if this handbook would ever decide to open.
I gotta yell that for a second.
What? What are y'all talking about?
I really wish you would just sit in there for a solid semester and try not to bang your head off.
I think it would be funny if you just had him start covering your classes for you.
I think it happened before.
And you'll learn what this is.
Okay.
Did he tell you he's heard what exception?
Why don't, instead of having online lectures, you just have our favorite professor cover for you?
Well, I don't even know what you all are talking about at this point. Wait, am I spelling that correctly?
I can't find it because I spell.
Century.
I know it's that's gonna have something in there. Hold on. Like they rearranged this manual because it used to have like that was the solution. Hold on. Say it again. Plane circular motion. Let's try that. Hold on. Wait. We have plane motion. Plane circular motion. There we go. Here we go. All right. What's that? This is interesting because, like, the formula in a previous manual was literally just right here. It was just mv squared over r. And hold on. Yeah, I know. Hold on. Now this is bugging me. Let's see. You tell me if you can find it. I'm looking for it myself because I know it's here, you know. Centripetal force. Yeah, if I've got the plane circle, it used to be like right there. It was, I mean, it was literally. I had this problem in the in my notes because I was trying to point that was the formula right there. And then they changed the manual, and then it's not right there. You know, you might be onto something. Yeah. It used to be right there. What's that? Well, that's a good. I don't know how do you.
Good luck.
Yeah. Yeah, I had that was like kinetic. Yeah, mv squared, half mv squared. Oh goodness. See, this is why I don't like dynamics. So. Right here. Yeah, this is why. Hold on. Let me try something else. Okay. I was trying centrifugal, and it wasn't there either. So. What's that? Oh my goodness. It's, I don't know. I know that the answer is mv squared over r because this is a plug and chug formula in basic physics, and then it's not here in the manual. What's that? Is there a physics? There's not a physics section. It's just statics and dynamics. Honestly, at this point, I'm telling you, I promise you. No, it's D because FC is mv squared over r. I like this is basic physics. The fact that the formula is not listed is actually kind of bugging me a little bit. No, in fairness, actually no, because it does list, basic relationship between position, velocity, and acceleration. So, I don't know. Yeah, that bugs me. I will. Moving on to ethics. That's what we're doing. That's what we're doing. Okay. Yeah, yeah, it is. That bugged me a little bit because it used to, when I developed that problem, it was literally right there. That bugs me. I don't know. All right. Move on. Okay. I don't have to write anything down for this one. This one's kind of cool. There's no problems I have to scratch out. So this is actually kind of cool. This is ethics. I don't have any calculations to do. I just have to talk. It's a lot easier for me. All right. Let's talk about ethics. Okay, so one of the things to keep in mind on the exam is that it's not just ethics, it's ethics and professional practice. So you're going to be asked questions not just about what is ethical, but what is professional in terms of things like contracts and appropriate business practice. But in the end, there's two things I want to point out. Number one, this stuff is like, I know after that last problem, this is going to sound pretty bad, but that stuff is in the manual. And two, here's another thing about ethics. A lot of this stuff is actually common sense, if you think about it. I'm not saying that these problems are not, I don't want to say challenging. You have to think about them, but there are actually well-defined, straightforward answers if you take some time and digest them, okay? Who said that? Did I say that?
Probably be hard for
I think I was far enough away from the microphone. Okay, all right. Let's look at problem number one. This is I know y'all laughing. This is a straight problem out of a reference handbook on this topic. So, when may professional engineers make political donations?
D. Only if it is.
Hold on. Why did you say C? But what this says is that only if donations at all are made as an individual and do not represent a firm or entity. Are you saying that firms can't make donations? Are you saying just a firm, like if I own my own consulting firm, that like that firm can't make donations? Yeah, that happens all the time. Yeah. You're like, great first question, Dr. Mike. Okay, D, what is a specified amount for a political donation? Is there one? No. Is there anything in a specified donation amount in the Code of Ethics in the reference manual? Oh my goodness, John. Look at it.
How am I supposed to look at it?
It's too difficult. I just say don't make donation at one time.
You can't make a political donation ever.
After all
I don't even
this,
know. What is B getting at? Like, why would you give?
You say you make a donation, but not for input.
Why would you?
Is it
Why would you do that?
Is it ethical to put money into somebody?
Maybe if you're, how about this? How about this? Maybe if you're a civil engineering firm and you give a donation to a congressman that institutes a project in your district that you get to bid on or something.
Yeah, isn't that? Isn't that being influencing?
Guys, it's B. Like, yes.
So,
I don't
it
understand.
determines if you did it for the influence that it may have.
That makes no sense.
Or not, like, how do they know, like, you're intentional or not intentional?
Hold on. You're asking the question between what's legal and what's ethical. Okay, all right. Now hold on. You're differentiating between what's legal and what's ethical. You're asking how are they going to catch you? That's not what the question's asking. The question is asking what's right or wrong.
It's in here.
All right, hold on. Okay, something that we all might not have discussed, but maybe I ought to go ahead. There is a difference between actions being ethical and actions being legal, okay? There's a big difference, okay? All right? Here's an example. What is so funny?
Sometimes things are illegal and unethical.
Just act like it's not going on. We lost it.
Yes, it's
I'm not, but
It's on page 4.
why would you?
Page 4.
Hold on. We got a question, and then I'm going to entertain what you just said because I want everybody to hear it. Go ahead.
I'm confused about the influence part. I mean, isn't making a political donation influencing?
Not always.
Well, you...
Yeah. It says, licensees shall not offer, give, solicit, or receive, either directly or indirectly, any commission or gift or other valuable consideration in order to secure work, and shall not make any political contribution with the intent to influence the award of contract by a political authority.
So you mean like he could give a donation because he want his taxes lower, but not because he wants to make a
Right.
project, basically. So he's influenced, but not influenced by his job.
Okay, what if I want to overcharge for engineering services? Next question.
Hold on. Oh, my goodness.
So it says with the intent to influence, so like what if you donate $25 to Brooke's campaign and 2 years into her term, she's like, all right, well, every civil engineer in my district's getting work. Can that come back on you? Like, because you donated?
Did you know it was going to happen?
No?
Wouldn't that be okay? But like, if I were to contribute that $25, that would be why I would do that. Like, that's my hang-up, is I'm not understanding why you would.
Next time.
You've never thought of the idea of just contributing to a candidate just because you supported their policy?
I'd rather give a $1.
Oh, my God. Oh, my God. Okay, all right.
Okay, so you're saying it's not illegal, it's unethical. So what are the consequences of doing that and it being unethical? And in terms of like making.
Can you lose your
a
license?
contribution for influence.
Can you lose your license for unethical behavior? Yes, you can lose your license for unethical behavior. Look, let me give you some examples. Hold on. Let me give you some examples of legal and unethical behavior. Okay, would you like an example of legal and unethical behavior? Okay, here's a very recent example of legal behavior which was unethical. All right, 2008 financial crisis. Everybody remember that? Okay, all right. Now hold on. One of the banks that actually didn't do so bad in terms of the financial gains at the end of the financial crisis was Goldman Sachs. Okay? One of the things that Goldman Sachs did, how many of you have heard of a financial instrument called a derivative? Okay, so long story short, a financial derivative was a way of betting on whether or not housing prices and mortgages would be profitable or not under a given investment. And basically what the investment banks did is they took all these mortgages, they packaged them into these investment packages and sliced them in pieces called securities, and then people would write derivatives on those securities to see whether or not they were profitable. Okay, so here's long story short. Okay, Goldman Sachs would go to clients and say, bet on these, invest in these derivatives, invest in this, bet on this, it's going to make money. Meanwhile, their own risk department was betting against it. Okay, so here's basically what was happening with their clients. This is going to make you money. You're going to do great. Sell, sell. Don't worry, it's fine. Get rid of it. Get rid of it now. All of that completely within the confines of the law. And a lot of people lost a lot of money based on very legal behavior, but I would argue that if an entity was telling their clients, give us your money and we'll invest it wisely, and then at the same time betting against those investments, I would consider that unethical. I don't know about you. Very highly unethical, but legal.
Do you have any good examples of things that were illegal and unethical from recent times?
Like murder? Like, would you like an example of vice versa? But go ahead. Hold on.
This is probably like an obvious answer, but you mentioned if your firm or whatever contributes money to a candidate from your area, district, and you think you might get more jobs or contracts. That's unethical.
Yeah.
So we just take it and say it's safe to say, don't give no money
Wouldn't A
to a
be the better
politician.
answer?
That's what I thought.
Because it'll save you a lot of hassle.
Because what if?
Because what if, the what if factor.
Like with,
So you're saying that as what if your free speech should be curtailed? That's what you're saying?
I don't know what that would be.
Yeah, I'm perfect. We don't read.
We can tell that.
God.
All right, next question.
Hold on. Yes.
But I'm like legit with him because like I would just say don't do it at all because if Natasha really did give $20 to Brooks' cause and then maybe 5 years down the line it turned in my favor, could that turn back on?
Yeah, but that's not like illegal. I mean, that's just saying that, like, that wouldn't be considered unethical just because, like, it's just nothing really happened.
Think about it like this. The road bond that got passed in West Virginia, there's work done in all 55 counties. Now, some counties got more than others, and some of that makes complete logistical sense. For instance, you know why they didn't get, there's not one single interstate road work contract awarded for McDowell County. Why was there not one interstate road contract awarded in McDowell County? Because there's no interstates in McDowell County. So some counties and some regions got more money than others. Not politics might be subtracted that for reasons just like that. Okay, you see what I mean? So you know this notion, and I don't know why people threw Brooks' name out there. Like, I don't know why people threw Brooks' name out there. But the point is, look. You can contribute to a political candidate, and if that political candidate makes a decision that benefits or hurts you and has nothing to do with your contribution, it is what it is. But if you gave money to this candidate with the express intent of, I give you this money, that's going to give me a contract, well, that's unethical. Yes.
Okay, well that's okay.
What if it's not just you individually, though? Like, you think they'll just be better for the overall economy?
That's fine.
Well, it's going to get you more jobs.
But who judges it?
Yeah, I think this is more of a personal.
You judge
You know,
this.
you went to dinner.
Guys, this question is meant to test your understanding of these concepts. I think you're...
Obviously not again. I think that's the issue here.
Guys, I think you're going to... Hold on. Why don't we go to the next question, and let's see how we do. Y'all are worrying me, man. All right.
It's not always.
Which of the following... Now, hold on. I'm going to give y'all a second to read this. Which of the following is not always an ethics violation? No, it's not. I will say this. I will say this. The way that choice D is worded, I'm not the biggest fan of. I will go ahead and tell you it's not D, because what D is basically saying is that if you're receiving fees to get a job, like basically related to what we're saying with number 1. It's not D. Okay, I'll go ahead and tell you that it's not D. It's either A, B, or C.
What type of officer is Steve referring to?
Is that saying like he owns the company, yet he's also the person paying the?
Yes.
But here's the thing. So if you're serving on the board, you never get.
Hold on. These are great discussions. Say that again. That's what choice A is saying. Is that ethical? Yeah, that's exactly right. It's not ethical at all. You as an engineer cannot certify a design you don't know anything about.
I would say B, what if the confidential information is harmful to the public and you have a duty to?
Let's give this guy a blue ribbon because it's B. He's exactly right. He's exactly right. Listen. No, it's not. No, it's not. No, it's not. And let's go into this. I want to address his answer, which is the correct answer, by looking at this one. In the event of an ethical conflict, to whom does the engineer hold the least ethical responsibility? Let's talk about an ethical conflict. You work at Samsung, and you're an electrical engineer, and they come out with the Samsung Note 7, okay? Now, I'm not kidding. I'm not kidding. This isn't this. I mean, I know it sounds funny, but it's not like what we're talking about is incredibly serious. I mean, like if there was an electrical engineer on that team who knew that it was going to be a safety hazard, if they knew, okay, they might just not have known. I haven't looked into the specifics behind the inner workings of the company, but if they knew, if they told the public or the regulatory agency or what have you, that would have violated the company's confidentiality. Samsung has a right to keep their internal, their internal knowledge confidential. If I'm working for the Apple iPhone development team and Samsung offers me a job, well, I could take that job, but I'm going to know things about what's going on at the other company. So.
It sounds like a bonus.
Jesus Christ. Say it again. Exactly right. The answer is A. When it comes to an event of an ethical conflict, where's your least responsibility? In the last problem, we had an ethical conflict. What we had is a scenario where if you're an engineer and you're working for a client where you have a confidentiality agreement or anything like that, but you're working on something that ends up, then this will be a danger to the public, that comes first, okay? So there is a hierarchy in terms of who we as engineers hold our ethical responsibilities to. Society is the biggest. The least important is our employer, okay? That's the least important on this list, okay? Because even your employer is beholden to the client, okay? So they would be next, okay? The consumer, it's basically society, yeah, in this scenario.
If you were working for a company and say there was a safety hazard and say you did, let that be known to the public or whatever, the employer could, obviously there's a job or that, but if you have some type of non-disclosure agreement with the company, couldn't they then also sue you for breaching that?
First off, a couple things.
I
And
know that's legal, so
No. Well, let's explore this because this is kind of important, okay? We don't really have a formal discussion of ethics in our curriculum. I've been doing it in co-op here recently, but...
I'm not even in co-op, neither is Leo.
Yeah. Hold on. Let's talk about this. We got time, and this is really important, okay? I'm going to throw a couple examples at you to address your situation, okay? Let's say I'm a bridge inspector, okay? And I'm doing a bridge inspection of a composite steel plate girder bridge. And I'm doing the inspection, and I notice a couple bolts are missing or some bolts are loose on a particular bolted field splice, okay? Let's say it's a few bolts. Let's say we're starting to get to the point where the connection could come loose, okay? I'll be honest, I don't think an appropriate response is to go on WSAZ 6 o'clock news and tell the city, okay? Look, guys, I'm being serious about this because do I think that safety, issue should be reported? Yes, I think it should be reported, okay? Report it to your boss, report it to the DOH, report it to the appropriate regulatory agency. It does need to be reported. You don't need to create a panic about it, but you need to ensure that the safety violation is addressed. But okay, let's talk about that. Let's continue that scenario. Let's say that you're a chemical engineer that's designing an industrial plant for the manufacture of a solvent or something, and you're designing the chemical process, okay? And then your boss comes in and says, well, there's a new valve that we're going to spec for this given system, and we're going to use that for this project. So you do the design, and you find that valve is going to bust and it's going to kill people, okay? So you document it. You tell your boss, okay? You say, hey, we're not, if we use this valve, it's going to be a problem. And your boss says, fine, great, thank you. I'm glad you pointed it out. We'll take it under advisement. And then 12 months later, you go to the site, there's the valves, okay? Now, you told your boss didn't do anything about it. You can tell him again, say, hey, I mentioned this and it didn't happen, but what I'm getting at is this. If it's still a safety violation and it could still kill people, what you as an engineer, I mean, I know everybody's like, well, there's a paper trail and I sent the email, and if somebody gets killed, well, it's not on me. I'm saying, yeah, it is on you because you knew there was a safety violation and you just let it go. And you let workers continue to work at that industrial plant and they died. You know what I mean? Just because you sent an email doesn't empty the coffin, of that industrial worker that died,
You're just one person, so if you say you think it's going to kill people, but your boss is higher up than you, and maybe more people decide, no, it's good, then,
If you get to the point, if you get to the point where you are that conflicted, like if you get to the point where you've told everybody up the chain and nothing happens, at that point it's time to go to the regulatory agency. Well, what I would say is in our world, maybe like the DOH, maybe that's appropriate. Maybe EPA if it's an environmental situation. But you as an engineer can't just let that happen. Like you can't just let the public or a client use one of your solutions that is going to kill people. Like you just can't do it, I'm not saying go to the 6 o'clock news and your first step is to get federal whistleblower status. I'm just saying that you can't allow that to continue. Yeah.
What about like something like Geotech? I feel like it's kind of like wishy-washy. Like you might think it's dangerous, but someone else might think it's fine. So then, like, how do you know when to think it's dangerous?
That's a good question. That's a good question. Let me say this. Geotechnical engineering, and so this is a really good point, and I do want to get to our next two questions. We do have time. It's not like we're running out of time. We got plenty of time, and I do want to talk about them. But let me say this about geotech. Geotech is a highly variable scenario. It is, okay? And we all agree that you could do a boring log here versus do a boring log there, and you're going to get different solutions. We all agree with that, okay? However, okay, we are in West Virginia. We're in the tri-state area in West Virginia. And there are certain soil characteristics that are native to this area, okay? We're not going to get the same soil profiles here than we will in Nevada. Okay, there is certain characteristic of soils here. Okay, number two, there are, I mean, granted, while soil properties change on straightforward scenarios, I mean, like if you're designing a retaining wall, I mean, like a company like, I don't know, H&TB or Triad or Baker or whatnot, they've been designing retaining walls for years. So even though soil properties are variable, with solid engineering judgment and factors of safety, you can be assured of that design. Okay, the scenarios that you're talking about are what I would call like what I'm saying is a real life scenario where what you're talking about would happen. Would be something where the design is very, very complicated, like a very complicated geotechnical engineering problem, like a complex slope stability problem, or you know, some three-dimensional stuff where it's really tricky. And in those scenarios, when you're that uncertain, your factor safety goes through the roof. Really, that's what an engineer is going to do to ensure that the ethical situation is gone. If they're unsure, they're going to take that factor safety of 3 and bump it up to 4. Okay, and they're going to make sure it's fine. If the scenario you're talking about happens, it's because somebody's trying to cut corners and save money, and it's usually pretty clear. Even though geotechnical engineering has a little bit more uncertainty, we as engineers handle it by using larger factors of safety. Usually in that end, though, it would be, you'd know if somebody was trying to compromise safety. So I would think so. Are there any other, like, this is, people when they say, oh God, we're talking about ethics, and then people get fired up when you talk about it. Like, I'm serious. I always thought it's because people thought it was boring. It's not boring. It's probably the least boring topic we talk about in engineering.
Who decided?
Oh my goodness. Oh, you were supposed to be in here for another 30 minutes.
We can tell you're hungry.
Grab a Snickers.
All right, how about this? How about this? Who owns the rights to inventions that arise during work for a client if no prior specifications regarding inventions are made?
If I didn't design anything, it's fine.
Or if you're using
Hold on. Who agrees with her?
That's right.
The company's gonna try to get it whether or
Yeah,
not you like it.
whenever I started at Clorox, that was the first thing I saw.
Government too.
It's the company. Because when you sign, when you work for a certain company, they have like a thing where like if you do invent something on the
Maybe it's a
no, if you invent something,
Guys, go ahead.
if you invent anything while you're at work, technically it's the company's invention. That's what happens when you sign your work.
You accepted the job, you work for the company, whether you sign a specific agreement.
But who pays the company?
client. I think it's the state.
Well, first off, I can promise it's not D since we don't live in Soviet Russia. Look, I know you might not personally like it as the inventor, but the answer is C, okay? Because here's the thing. If you're working for a client, so if I work at a consulting firm and I'm an environmental engineering firm and a client has hired me to do some investigation, and in the course of that investigation I invent a new process for detecting some chemical, well, I would not have done that if I wasn't working for that client who was paying me an hourly rate the entire time I was working for them. They paid my salary while I was doing work for them.
So the way to think about it is the client is the owner.
Yes.
Whoever has the money.
But what about business to business?
You have a comment on that?
What do you think?
He said, what about business is business?
Yeah.
What if you just like withhold some information?
Yeah, business to business, right?
Withhold information from your client? Guys.
Could this be compared to like a landowner having someone come out and do like drill testing on their property and they find minerals or oil or gas or whatever? They found it, but it's on their property, so it's theirs. Is that right?
That's why you have the mineral rights.
Yeah, and it's not, the difference is it's not like an invention. It's not a creation of a new idea that we're not aware of. That's the difference, I would say.
So how do you get to that? With the done project, do you go to them and it's like, hey, by the way, I also have this cool little
Well,
prototype.
that's a good question. The answer is this, okay? First off, what you should do is, if that was going to be a potential for your given project, you should have had that agreement in place from day one. So, for instance, if I, as a faculty at Marshall University, invent something, okay, and it gets patented and manufactured and it makes money, well, if I was on the clock as an employee at Marshall and Marshall was funding my salary and my time while I invented that, and I was using, let's say, Marshall's facilities. Like if I was some chemist and I was inventing some new chemical and I was using Marshall facilities and using Marshall test tubes and Marshall reagents and what have you, well then Marshall has a stake in that, because without them it wouldn't have happened, okay? So whenever that happens, and that does happen in academia quite a bit, usually there is an agreement that's put in place between, Marshall gets this much, you get this much, this much, and so on and so forth.
Do you have one of those agreements?
I haven't invented, some new gizmo since I've been
But
here.
I mean, like, something that is just like already in place, if they already have that worked out.
Most universities have standard practices developed, yes. I mean, we have faculty here that have patented stuff. That's not uncommon to universities, so. All right. In all honesty, these questions are probably these are probably some of the most challenging ones. No, they aren't. This stuff hasn't changed. But funny. What do we think? It said which of the following is not an ethical violation? Do you think C is an ethical violation? Proceeds. I spelled that incorrectly. It's EEDS. Sorry. That's going to bug me. I don't, that is spelled correctly.
I can see how you would miss a spelling mistake with that.
Hold on. Do we think that C is an ethical violation? What's that? Exactly right. It is an ethical violation. Okay? All right? Because you have to think about it like this. If those products are designed, or if you're working for a given client, what are you going to do? Take, one client's benefits and move it over? No, you can't do that. What about A?
Everything has a design line, so you have to kind of think that odds are that brick is not going to live 150 years if its design line says that.
That's true, but what if I designed, let's say, a
You wouldn't want it to just fail though at 70 years.
no, but what if I'm a mechanical engineer and I design, let's say, an electric razor or something to only last 2 years? Because it's funny. Because it's funny how. Let me finish. I'm glad to see you all are passionate about this, but let me finish. What if you design a razor, electric razor, to last 2 years and 1 day, because 2 years is how long the warranty lasts?
That's wrong.
You're right. It is wrong.
No, that's with everything, bro. As soon as the Xbox warranty go out,
Now, what about B? But is that unethical? I'd say it's not. You're telling your client, you're telling the consumer, here's option A, here's option B. That's fine. In fact, if anything, you're putting it all out there on the table. You're telling them, here's your options. Now, what you can't do is charge a premium for a safe product or charge a premium for a product that meets the specification. Like, well, if you don't give me this much money, I'm going to give you something that's going to break apart in your hands. Like,
Have seatbelts in your car.
I don't really understand about A's ethical violation because, like, if your company and you make a razor, electric razor, you think the last 2 years, and you say, I guarantee you the last 2 years. Why is that not, like, why is that unethical? That if it breaks after 2 years, well, I can guarantee it over that. Like,
there's a difference between designing something to fail in a specified number of years and designing so that it lasts its intended design life.
Yeah.
Not necessarily. Not necessarily.
I just feel like if we design a bridge to last 75 years, we're not going to design it to last longer than that.
But you're not gonna, you don't want it to just fail at 75 years. You know, like you wouldn't want it to just collapse at
Happy New Year's,
76 years because you only built.
How about let me extend his point a little bit. Everybody relax. We got time. Let me extend his point a little bit. Okay. What if we do, let's say, some research on the life cycles behavior of commonly available structural steel, not new stuff or brand new product, just regular old everyday structural steel. And we find that regular old everyday structural steel under proper conditions will last for an average of 104 years. Okay, so that meets your 75-year design life. Is the answer then, well, I'm trying to word this appropriately, well, I'm going to use a substandard material so that it'll hit that design life, or just use what's commonly available? Like, you see what I mean? I do see where you're getting at, with the gray area. And that's actually sort of what I like about some of these ethical questions. I like the gray area questions. I'll admit these are difficult questions.
You need to know, like,
What's that?
you need to know, like, the intent more than anything.
You're right. You're exactly right. You're exactly right. And honestly, ethical, like really good ethical questions are gray. Here's an ethical question for you that's gray, and we'll leave it at this because I know everybody wants to leave. We'll leave it at this. All right? We're going to get some America answers with this one. Okay. All right. When you're an automobile manufacturer, you are required under regulation to place additional appurtenances in your back seat, specifically between this cushion and this cushion. What you're placing there are a couple of metal hooks. What are those metal hooks for? Baby seats. Okay, now what if you are, now here's the thing, you as the consumer, whether you like it or not, when you buy a car, you are paying for those hooks, okay? So what's happening is this. As the consumer, or as the country, what we have said is this. We have said that to ensure uniform safety across the board, everybody buying a car is going to buy those hooks, okay? Now what if this is America, I should do with my money what I want. What if I'm somebody who's never going to have kids? Obviously not my case, but what if somebody's like, well, I'm never going to have kids? Well, the motorcycle. But in all seriousness, we as a society have said that in order to ensure uniform safety across the board, we are mandating that everybody's going to spend that little bit of extra money to install those hooks in everybody's car. Should we do that? Should we enforce mandatory safety on everybody? Like, if you buy a car, you might not need those hooks, but do you want it set up so that anybody who buys the car has that option? I agree, but I'm saying,
And if they're so dead set on not wanting them, they can buy a car made before 1961 because they weren't required before. They ain't got seatbelts.
Ralph Nader messed us all up.
Did you say Ralph Nader messed us all up? not even so much that. A lot of this is just basic common sense. The long and short of when it comes to these problems on the exam, if you just make sure that you're placing society and public safety above all others, and then, client confidentiality, not bad-mouthing other engineers, you're usually doing pretty good.
That's kind of tall, right?
I'm stopping the recording on that one. My goodness. You all have a wonderful weekend.